Okay, I might just start with the introductions and we'll give us a few more minutes for people connect. Welcome to the seminar series today. Caroline Holden will speak shortly, and I think when she starts talking, the image will switch to her. Anyway, I'm David Johnson, the Deputy Director of QuakeCoRE here at Massey University in Wellington, and it's really good that such large numbers are joining us for this event, beamed across New Zealand and the world maybe. And also we've got people in the lecture hall who we can't see, but we saw you coming in. So, but Caroline Holden's going to be talking about the It's Our Fault research program that's been running for over a decade now. And I'll let her, in her presentation, will give some more context. But Caroline is a scientist at GNS Science, and maybe I'll even let her give a little background about her, where she fits into this, but has been an active member of QuakeCoRE and has been working for a long time in New Zealand on a number of these issues. So maybe I will ask Caroline to introduce, but just a few housekeeping rules. So thank you for coming on board. If you can keep your microphones on mute, but we will have a Q&A at the end, so there'll be a chance to ask some questions in the last 10 minutes of the time. And this is also being recorded, so this will be available for others. If you enjoy the session, you can post it or link people to it. So without further ado, we'll invite Caroline to introduce herself and to the topic about the It's Our Fault program. So welcome.
Right, thank you, David. I'm going to start by sharing my screen. So hopefully, okay. Can you let me know if you can see the full screen? Is that okay, David? Can you see the?
Yes, that's good, thanks.
Fantastic, it's working. Awesome. Ina mana, ina reo, ina karanga maha o te wā, tēnā koutou katoa. Ko Flandre te manaya, ko Lis te awa, no France, rawa, no New Zealand, ahau. Ke seismologies ahau, or he seismologies ahau, ke te pu au ahau e mahiana. Ko Caroline toku inoa. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. So my name is Caroline Holden, and I'm a seismologist at GNS Science. And I also have the privilege to be the science lead for this beautiful research program called It's Our Fault that I'm about to present to you guys. But first, I'd like to say first thank you to the program funders, EQC, WMO, and Wellington City Council. And also, I'd like to say a big thank you to QuakeCoRE for giving us the opportunity to present this research program. I'd like to highlight that I'm presenting on behalf of the It's Our Fault team. So this is my chance to shine and to take credit for all the amazing work that the team is doing. So it's a real privilege. Before I get into the It's Our Fault specifics, just wanted to highlight that It's Our Fault is part of a multitude of natural hazard programs that are currently funded around New Zealand. And so this is a beautiful illustration by Alice Lake Hammond of the different region-specific programs that are currently looking at various parts of New Zealand. I believe the It's Our Fault research program is the oldest one. It started in 2006, and it's potentially the one that deals with the most hazards as well. Earthquakes, so ground shaking, liquefaction, landslide, fire falling, earthquake, tsunami, but we don't have volcanoes. So pretty much all the hazards except volcanoes. So it's just nice to give like to knowledge of the other research programs that are currently ongoing in New Zealand as well, and It's Our Fault is one of them. All right, so in this short presentation, I will first present the objectives of the program, and then I will present what I believe are the three pillars that really brought the success of It's Our Fault. And then we'll look at the exciting part, which is the accomplishment and the current funded projects. So we'll start with the objectives of this program. But first, I think it's important to step back. This is a really long-running program that started in 2006, and it's important to go back to 2006 and remember what the seismic hazard knowledge was at the time. in 2006, the Wellington fault was actually driving most of the seismic hazard for the Wellington region. So it was the likelihood of a large magnitude 7.5 earthquakes on the Wellington fault was thought to be very imminent. And the question was actually, you know, at the time, is the big one overdue? So there was a need to actually better identify and to better understand the likelihood of a future Wellington earthquake, right? The other context, the other part of the seismic hazard at the time was the subducting Pacific plate. So the Hikurangi subduction zone that sits 23 kilometers below the Wellington region was just starting to be identified as a potential candidate for large ground shaking. But we knew very little about it. It was just the birth of better understanding how the Hikurangi subduction zone could contribute to seismic hazard in New Zealand, and particularly in the southern North Island, the Wellington region. So in terms of seismic hazard, we had a lot of work to better understand, better characterize and better understand the seismic hazard in the region. The other part of what was going on in 2006 is that there was a pretty messy world of natural hazard into land use planning. And I see it here, I'm quoting my colleague, Dr. Wendy Saunders, who had, she designed this beautiful diagram, and it's a bit of a mess here, trying to understand how the science fits with the decision makers. So the key messages of this particular illustration here is the clouds represents on the left side, you have the white cloud, which are the researchers or the scientists. And on the right-hand side, you have the other clouds, which are stakeholders, decision makers, local authorities. There used to be a big gap between researchers, in terms of natural hazard, between researchers and these agencies. Sometimes you had consultancies that were able to provide guidance and some level of hazard information to those decision makers, but there was a bit of a question in terms of how much connection was between researchers and consultancies, and how this was translated with stakeholders and decision makers. The third component of this really excellent diagram that sums up the situation at the time was the influence. And so influence is represented here in the form of those big pink clouds here. So you have funding, so how the science is funded also provides strong influence on which science will be funded. Obviously, you have governance and legal framework that also influences the type of science that will be funded, the science projects. And finally, but really importantly, is the community and the public opinion as well. That will influence what kind of science they would be interested in seeing funded, and kind of risk appetite they would be into developing. So this is the context back in 2006. So seismic hazard needed to be better characterized, and we have a bit of a messy world between science being translated into applied deliveries. And so this is where the itself of research program came in, so 2006. And the objectives at the time was to see Wellington being better positioned or to be very resilient against earthquakes, and doing so by studying again the likelihood of large Wellington earthquakes. So that was the first phase of the program. The second phase was looking at the effects of these earthquakes in terms of ground shaking and tsunami and landslides, for example. And the last phase of that program was the impact of the hazards on humans and the built environment. So this was the core statement of the program in 2006. And since then, I have to say happily that it has morphed into now more like fostering this growing level of earthquake resilience in the Wellington region. So it's really acknowledging that we've come a long way from 2006 to now. And actually, there is a really stronger resilience in terms of natural hazards in the Wellington region. So that's fantastic. And so the program is really now looking at fostering this momentum, fostering this growing level of earthquake resilience. So that's, in a few slides, the objectives of the program. Now I'm going to talk about what made this program so successful. So I was privileged to be called into the program a couple of years ago now, and I was humbled to see how successful the program was. And also as a scientist, I always think, you know, science excellence is the driver, and that's what explains why programs are successful. But coming into the itself research program, there were actually three components that really made this program very successful and long-lasting since 2006. So the first one is obviously research excellence. So I'll explain a little bit more afterwards. The itself research tasks are actually based on science excellence, not just with excellent scientists, but also with excellent collaborations. So it's important, you know, New Zealand is a small country. It's important that we keep collaborating and learning from each other. And actually, a few years ago with Holden, we set up this Wellington Collaboratory, which is an umbrella organization that helps to focus and gathers any research that's going on in Wellington earthquake resilience space. So the first component is, you know, research excellence. It's a no-brainer, you've got to have this. The second part is actually, you will be all aware that in the last decade, New Zealand has experienced a lot of major earthquakes, and we need to be learning from those earthquakes. So we have a lot of data, we have a lot of experience, we can learn from all the impacts of the earthquakes, and it's really important to make the most of these earthquakes and to build a more resilient nation. And the last part, and to me that was the most, it is the most important part of the success of itself, is the fact that these guys were able to work, and we still are working with communities. And I'll explain a little bit more afterwards, but it means communities in a broad sense. We've been working with individuals and making changes at individual levels, so empowering individuals to be better prepared for earthquakes, at community level as well, and also at very high level decision makers, planning and policy levels. So it's really important that we keep engaging with these guys, and also that they are telling us what they need and be able to understand the science to tell us what they need. So yeah, in summary, these are to me the three pillars that really made the itself a really successful program. I'm just going to explain a little bit more what I meant by research excellence, and also there's some really important take-home messages in there as well. So it sounds a bit odd, but I like to illustrate the research excellence with this iceberg illustration. And if you just consider that the tip of that iceberg is natural hazards. So ground shaking, so for Wellington, we've got them all, right? Ground shaking, liquefaction, landslides, tsunami, fire. So that's just the tip of the iceberg. But to better understand this particular hazard that will impact Wellington region, we need to have a really robust understanding of the fundamental science that goes behind that. So whatever we need to understand, the very tip of the iceberg really relies on robust and fundamental science that supports it. And so these are really large research programs. This is not itself. These are really large government-funded or internationally funded research programs that allow to have a very in-depth and robust fundamental science system at points. But we have to go back to that tip of the iceberg, which is the natural hazards that really concerns our Wellington region communities, right? So that little boat here, that's all they can see. They can see potential ground shaking, tsunami, fire, liquefaction, and so on. And they're really interested in making a difference. They want to make Wellington region more resilient. And so this is where the itself of research program was able to pitch in by connecting scientists that have this excellent research or science knowledge with these Wellington region communities in a broad sense. And so this is where the program is actually putting in the same room research excellence, as well as end users that need that research. But they also need to understand the research, right, to be able to express what they need. And also scientists need to understand what kind of deliverable or output will actually make a difference for these people. So now again, you know, having those, this submerged part of the iceberg, so the fundamental science is not just important because science is really cool and it's fascinating, but it's also in terms of the itself of research programs and also in terms of Wellington region communities. It means that the deliverable that are part of these programs are actually robust and defendable. And so that's really important because in the long term, you're going to change people's life by having new planning and new policies that includes the natural hazard context. You're going to change people's lives, and not everyone's going to be happy. You're going to need to be able to defend your output, your science output. And so this can only happen if you have a really robust base, a really robust support for your applied science. So again, itself is only funding this little tip of the iceberg, and it's really critical, but it also relies on the really robust, large fundamental science program. And so this is a slide to advocate for the need to keep funding these programs. Okay, so that was one pillar, that was the science excellence. The next pillar, so we had learning from earthquakes as well, but the next one that's really important, and that's, to me, that was a key characteristics of itself is the working with community side. So how did we achieve this? Well, first we worked closely with Wellington stakeholders. So the key Wellington stakeholders, so EQC, REMO, Wellington City Council are also the funders of the research programs. We meet with them very regularly. They influence decisions. The work plan is decided every year. So every year we discuss the work plan and we adapt it to suit their need. We don't always agree, we have to discuss a lot, and it takes a long time. But really, it's just to ensure that there's value in the science that we can deliver. The science we deliver is useful and can be useful as well. So the Wellington stakeholders are really important. Also, the other key point is that actually, as part of the research program, we just don't have tsunami scientists and earthquake scientists. We also have a really great team of social scientists, planning and policy scientists. So it's really important because these guys they understand the hazard language and also understand the planning and policy language. And so they're really a key component of the research program. They really help translating hazard into practice. Here's just an example here. And lastly, through the program, we've learned to work with existing tools. We're not trying to reinvent ways of getting science into practice. So some of the tools are actually just statutory, legislative tools. For example, itself pioneered soil class map for Wellington, and the soil class map is actually underpins the New Zealand building code. So that's one example. Another example is actually we work also through guidance. So non-statutory approach, just through guidance and guidelines. And again, the science from itself in the Tsunami Blue Line project provided the science support for the project. So this is just in one slide, how the working with communities works so well this program. Okay, I'm just taking time. Not too bad, I've got another 10 minutes. And now we're getting on to the really proud and exciting time, which is I get to show all the accomplishments and the current funded projects. I've actually switched the slide. I'm going to talk about the current project first, and I will finish with the accomplishments. Cool. So remember, our projects are actually renewed every year. So we discuss with the steering committee of the itself program, and we orient or we morph the project to be able to get the outcome that are useful for the Wellington stakeholders. The program always includes a natural hazard and impact side, also in the land use planning and policy component. For this year, in terms of the natural hazard and impact, we'll look at the subduction hazard again. We'll look at tsunami hazard. Fire following earthquake is a strong component. And also we're looking at the seismic monitoring of Wellington specific buildings as well. In terms of land use planning and policy, we have a very popular science to practice workshop series, and actually I talked a bit more ago, and we had about 40 attendees for 2 days discussing science with this. For this year, we're also going to be supporting the Wellington district plan in terms of the changes and how natural hazard can be included in the changes of the Wellington district plan. And also, there's this new national policy on the high density urban planning. that will impact Wellington. And so this kind of development is to include knowledge of the current knowledge on natural hazards. So the ITSAFO team will also be working on informing high-density urban planning as well for this year. Obviously, new projects and new collaborations are always welcome. So if you're inspired and if you have a project that potentially could impact Wellington region's resilience, please approach me or approach any of the ITSAFO team. Okay, so that's the project for this year, and I'm just going to conclude this talk by just going, I've just selected a few of the accomplishments of the research program since 2006. And yeah, so that's a really proud moment because there's some really cool science there and cool impacts as well. All right, so we go back again to 2006. Remember, we knew the seismic hazard had to be better characterized and the likelihood of large earthquakes had to be better studied. So this is what the program embarked on. You have to start from better characterizing seismic hazard. And so they looked specifically at the Wellington fault first. So that's the red line here. Wellington fault is capable of generating 7.5. Before the ITSAFO study, the likelihood of a Wellington fault was really high. It was 30% in the next 100 years. So not as high as the current alpine fault, but was still really high. After the ITSAFO study, there was significant reduction in the likelihood of a Wellington fault earthquake. So it was down to 10% in 100 years. That said, it's still a very active fault, and also the project was also able to identify new sources of seismic hazard for the region onshore and offshore. So there was collaboration with NIWA. So all those black lines here represent potential active potential sources of large seismic hazards for the Wellington region. So yes, the Wellington fault likelihood has been reduced, but there's no room for complacency. We need to build for a stronger Wellington region in terms of seismic hazard. So that was back in the early days of ITSAFO. Also in the early days of ITSAFO, we knew very little about the Hikurangi subduction zone, right? We didn't think it was active at the time. And we started to realize actually it can produce very large earthquakes. There was a locked region maybe underneath Wellington. So we need to really better characterize the seismic hazard that will impact specifically Wellington region. And so what the program was able to do, was able to leverage on very large research programs that were looking at identifying past earthquakes on the Hikurangi subduction zone to actually just contribute to those programs by adding some Wellington sites to be able to to better focus on the Wellington impact of the Hikurangi subduction zone. And so, but it's still, this is the tip of the iceberg. This is the little contribution of ITSAFO. But it was leveraging on really big research programs that were trying to identify past large earthquakes on the Hikurangi subduction zone. So to sum up, in 2006, we actually knew very little about how the potential impacts or the past likelihood of large earthquakes on the Hikurangi subduction zone. In 2020, it's really humbling to see that now we actually have a better idea of past large earthquakes. So this is works by Kate Clark, Nicola Litchfield, as well as, and we now have an idea that possibly there were 10 earthquakes in the past 7,000 years, and we also have a better idea of the size and magnitude of the earthquakes. So in terms of the seismic hazard impact on the Wellington region, this is big. And again, it's for being able to leverage some very applied focused research for Wellington, but leveraging on really large research programs. Also at the time, so we knew that we started to understand that the Hikurangi subduction zone was potentially a large source of seismic hazard, and so it's really pioneered first ground motion models for Hikurangi subduction zone for Wellington. Again, this was a small project, they were looking at very Wellington focused, but it led to bigger research projects and even to large collaboration with East Coast Lab, where we were able to simulate much larger magnitude earthquakes. Again, starting small, but building bigger research programs. A key program in the ITSAFO timeline was also looking at the need for post-earthquake earthquake sheltering. So this is really important for Wellington, where following a large Wellington earthquake or large earthquakes, people will have to shelter in person. So how do we accommodate this? There was a study. I believe that David and Johnson were involved in that study here. Oh, this is cool. This is a really nice. So this picture shows a rainwater tank reservoir, or individual water tank reservoir. This started with the realization, so when geologists looked at, so we're going back to Wellington Fort here. When the geologists looked at better characterizing the Wellington Fort, there was a realization that, hang on a minute, we have our main pipeline, water pipeline, that comes all the way north from Kentucky, from the water reservoir here, north of Wellington. That pipeline is pretty cool because it comes and feeds water all the way to the south coast. This is actually where I'm talking to you from right now. So that pipeline is really important, and unfortunately it crosses the Wellington Fort, I think about 7 times. So from the science perspective, there was realization we have a problem here, but the beauty of the research program is that scientists were able to engage with stakeholders and decision makers and to provide some input into potential solutions. So you could get the water from another source as well. So the Wellington Water Center to look at alternative reservoir source. Also, you can strengthening the water pipeline. So this is at very high stakeholder levels, right? But also, this project actually led to empowering people to better prepare for themselves. So Wellington City Council and WIMO are supporting, co-funding those 200-liter rainwater reservoir, so household rainwater reservoir that will help provide water for following weeks after an earthquake, when the water will be cut off for various reasons. So again, it's showing how like a research, so a science project is directly delivering into community space, and here it's really empowering individuals by preparing for themselves and by taking care of themselves, just making the community more resilient as well. So this is a really neat project, and I think I saw Mustafa Nayalu online as well, and he was one of the key contributors to that project, I believe. So that's a really, this is one of the neat impact that science can make. So from water, we go to fire. So for a long time, we had Jim Cousins looking at fire following earthquakes for the Wellington region. It's worth noting that fire following earthquake is a rare occurrence, but a really high impact one. And so for Wellington, where we have wooden structures, we have high wind conditions, and we have seismic hazard, it was really important to investigate the impact and the likelihood of fire following earthquake. So following on the Jim Cousins' early studies of this particular hazard, Finn Schill, modeling scientist, has been embarking as part of its Hapa research program on looking at more advanced model of fire following earthquakes for Wellington. So he's using more realistic characteristics of fire propagation and also more realistic conditions for the Wellington region, so more specific Wellington conditions. But also what's really important again here is that Finn directly works with fire emergency groups in the Wellington region. And so he meets with them regularly and he listens to their needs, and also he tells them what he can actually model and what kind of modeling would actually help them support business case or decision-making approach. So this is again showing how evidence-based piece of information can make a difference, a very clear difference with some particular resilience group. So this is really neat. So this is Finn talking. So he's an excellent modeler, so an excellent scientist, but he's also engaging constantly with the fire emergency group for Wellington. So that's really great to see. So I've talked about the tsunami blue line already. Again, great science input into a community resilience project. This is showing against science excellence, we have world-class tsunami models of GNS that help that are part of the itself of research program. And here is showing one of Jeremy's model of tsunami inundation when he includes Wellington buildings in one of his scenarios. So obviously, when you do classic tsunami modeling, tsunami model inundation, usually you put a bit of roughness on the ground. But then if you actually do the tsunami inundation model for a very dense location like Wellington downtown, the flow depth and the flow velocity will be very different. So it's really important to have very realistic values for Wellington City, but also this kind of models actually directly inform guidance documents into vertical evacuation for Wellington. So again, a very science excellence, just being applied through the discussion with stakeholders about what their needs are, and John and his team are able to model very well-specific scenario. Just a quick example of what I meant from one of the learning from the past earthquakes. Following the Christchurch earthquakes, there was a change in the Christchurch district plan that include learnings from the Port Hills land instability experience. And so Sarah Gall and her team analyzed, what the Port Hills experience meant and what are the implications for the Wellington region. So again, a really important piece of work on learning from how did Christchurch do in terms of managing landslide or land instabilities in their district plan, and how can we learn from that for Wellington. And finally, I think I'm right on time. This is an example again of excellence in science to practice as part of the program. And as recent as last week, we had this 2-day science to practice workshop series that was organized by Sarah Gall, Scott Kelly, and James Bevan, where they gathered for 2 days in the same room. They had earthquake scientists and planning and policy experts and emergency responders, just discussing current hazard knowledge and how this can be incorporated into land use planning. So again, it's not about zero planning or zero development. It's about smart development. And I'd like to say that for me, it was really eye-opening and very humbling to see, these are really busy people, and they came for 2 days to make the effort to learn more about natural hazards and to be able to make a difference in future planning. And to be honest, the planners are really at the forefront of earthquake resilience. They are the ones that by making smart decisions, we may not even need emergency response, right? Because we're going to develop our cities so well that we're going to respond really well to an earthquake or any natural hazards. And so it's really important to empower these guys, this profession, with as much as we can, and to include them in conversation as much as we can. And so last week's workshop, 2-day workshop, was to me a really nice illustration of the success of example. And I'm going to finish here and just sum up that this is truly a team effort. And then I thank all my colleagues and all the New Zealand earthquake scientists for their support. Thank you.
Okay, thank you very much, and very happy to take questions. If people want to maybe use the hands up, or even just come on board, and I'll acknowledge you and direct the question to Caroline. So do we have any questions? Do you want to stop sharing? That might help to see the screen.
Yes, let me do that.
I'll start with a question while others are thinking. So what's the future plans going forward, both in the next year and beyond that?
Yeah, so that's a great question. Compared to 15 years ago, the resilience space is very different in New Zealand. We have, as illustrated here, we have a lot of organizations that are working towards earthquake resilience. And so I see itself as being more collaborative and more inclusive into benefiting from all the research programs that are working towards making New Zealand more resilient. I also see there's a need. You know, we're not done yet with putting natural hazards in land use planning, right? And the illustration is that there's no such thing in the current Wellington district plan. There's no natural hazard component in the Wellington district plan. So until this happens, we need to keep pushing and to make smart, to be able to incorporate smartly natural hazards in land use planning. So it's pretty much continuity because we're not there yet. But also, I think it's really important to realize the community has grown, you know, since 2006, and so it's really important to benefit and to collaborate with excellent colleagues from New Zealand.
Thank you. Any further questions?
Everyone's just stunned.
Done. So I think from a QuakeCoRE perspective, we are very keen to further the links. We've been connected through the steering group since the beginning of QuakeCoRE. So we're sort of, and many of the participants are both in the It's Our Fault program, are active members of QuakeCoRE. So we have a link, and I think there's certainly looking forward an opportunity to strengthen the links between the CRIs and the tertiary sector through this program, and equally strengthen the sort of partnerships across other regions. So the AF8, EC Lab, sort of the alliance of the programs across it can both build, contribute to It's Our Fault, and It's Our Fault can contribute. From a sort of geographic point of view, It's Our Fault sits within the EC Lab program as well. So it's sort of geographically a subset of it by the boundaries of the EC Lab. So really strengthening those partnerships across institutions is something I'd be very keen to support, promote, encourage, and sort of working both ways. So as a QuakeCoRE, we are very keen to continue to contribute to It's Our Fault, and very much welcome It's Our Fault contributing to the efforts of QuakeCoRE. So, and there are lots of ways to do that. Just one final chance for any questions or comments, or but if not, we will take the opportunity to thank you and
thank you very much.
Yes. And thank you everyone for joining in and listening to this. And this has been recorded, so you can look back on the website and have the replay. So look forward to many of you joining in the next seminar or participating in the many of the upcoming QuakeCoRE events. And we may see a number of you at our annual meeting in December.